Hello everyone. In this video I will be talking about the second learning objective of week 5. Interpret frequency distributions, proportions, and measures of central tendency and dispersion. So we will start with making data usable. So when we talk about making data usable, actually we refer to arranging and organizing data so that the data carry some useful information for the researchers. So we'll be talking about frequency distribution, percentage distribution, probability, and some other statistical measures. First of all, frequency distribution. It is basically a tabular way of presenting data. That means we make a table, we make a summary of the data. What's the particular characteristics? In this frequency distribution, we show the number of times a particular observation appears in the sample. For example, if you have a score of final exam scores of 50 students and we make a frequency distribution, we will show that how many students got 70, how many students got from 75 to 85, how many students got below 50. So this is a frequency distribution. And percentage distribution is also a tabular way of arranging data, but instead of showing the number of times a particular observation appears, here we show the proportion of times a particular observation appears in a sample. And last of all, probability is the chances of occurring a particular event. Now let's see some examples. This is an example of frequency distribution. A survey was conducted among 3,120 people, and they were asked the question that how much deposit they hold in a financial institution. So there were 5 scales under $3,000, $3,000 to $5,999, $6,000 to $8,999, $9,000 to $11,999, and $12,000 and more. Now, respondents answered that how much deposit they hold. For example, 499 people answered that they have a deposit of less than 3,000. 530 people answered that they have a deposit of 3,000 to 5,999, and so on. So this is frequency distribution, as we are showing that how many times a particular response comes in the sample. And this is percentage distribution, very similar to frequency distribution, just instead of number, here we show percentage. For example, 16% people answered that they have deposit under $3,000. 17% people answered that they have deposit between $3,000 to $5,999. So basically, compared to the last table, what we did is that each category was divided by the total number of observation, and we express in percentage form. So this is percentage distribution. And this is probability distribution. As I already have said, probability distribution actually shows you the chances or the probability of occurring or appearing a particular observation. For example, in this case, as I previously mentioned, that the total sample size was 3,120. Now from this 3,120, if you randomly pick up one observation, what is the probability or what is the chance that that observation will belong to less than $3,000? There is a 16% chance. If you randomly pick up one observation, what is the chance that it will be $12,000 or more? So there is 26% probability. So this is probability distribution. So in this way, either the frequency distribution or a percentage distribution or probability distribution, we organize and present data to provide some information to researchers. Now we'll be talking about 2 statistical measures. One is central tendency, and another is dispersion. So first of all, measures of central tendency. So first of all, we need to know what we mean by central tendency. Actually, central tendency is a characteristic of data. In a data set, individual observations have a tendency to move around the center of the data. This is called central tendency. Let's take an example. Once again, we have 50 students and we collect final exam scores for all these 50 students, and we calculate average. Let's say average marks for all these 50 students is 70. Now, what is most likely that most of the observations, most of the observations of the 50 students exam score will be very close to this average, very close to the 70. This is called central tendency. That means observations have a tendency to hover around the center. Okay, so that's called central tendency. Now, there are different ways we can measure the center of the data. This is called median, mean, and mode. Mean is the arithmetic average. All of you know how we calculate arithmetic average. Median is the midpoint of the data. Okay, so if we have a median of the data, we can understand that half of the data set will be higher than this midpoint and half of the data will be lower than this midpoint. Mode is the observation that comes most often in a sample. Now let's take an example. We have some salespersons, for example, Mike, Patty, Billy, Bob, John, Frank, Chuck, Samantha. So 6 salespersons, these are the number of sales calls they receive. We want to calculate what is the center of this data. We want to calculate average, or we call it mean value. So the total of this is 26. So what we do is we first of all identify a variable. Let's say this, we denote this variable as x. That's the number of sales calls, and these are the number of calls, and these are the number of observation. So we sum up all these sales calls, the observations, that is 26, and we divide it by number of observation. You can remember number of observation was 8 and sum of the observation was 26. So mean value at the center of the data is 3.25. So these are the formulas to calculate mean or the average of a data. Now, measures of dispersion. Dispersion basically means how spread the data set is. Okay, how spread the data set is, how spread the observations are away from the center of the data. That is dispersion. Now, there are different measures of dispersion. We will be discussing 2 major. One is the range, another is the standard deviation. Range is a difference between the maximum and minimum values. For example, if you take a maximum value of a data set and a minimum value of a data set, and the difference between these two will be range. And you understand that larger this range means more spread the data set is, and smaller this range means more condensed the data set is. And standard deviation is how individual observations are deviated from the center of the data. Higher standard deviation means higher dispersion in the data set. Let's take this example. We have 2 products, product A and product B, and their sales, their monthly sales are given here. January sales for product A, for example, 196, and then February, March, 98, 99, 200, 201. January sales is 150, 160, 176, and so on up to December. So average sales for both the month are 200 and 200. However, you might have noticed that the spread of the data is not same. For example, for product A, the lowest sales is 196 and the highest sales is 202. The spread between the lowest and highest is only 6. Whereas in the case of product B, you can see that minimum sales is 150 and maximum sales is 261. So the spread between minimum and maximum sales is more than 100. So it's very easy to understand that A has more spread in its sales and B, A has less spread in its sales and B has more spread in its sales. So if we just plot these numbers in a diagram like this, so a low dispersion data will look like this and a high dispersion data will look like this. Now, as I already have said, that standard deviation is a squared deviation of individual observations from the mean value. Okay. Mathematically, standard deviation, higher standard deviation means higher dispersion and lower standard deviation means lower dispersion. However, for one data set, if we get in standard deviation, it is and it's not very meaningful because we cannot say whether it is more dispersed or less dispersed unless the standard deviation of a particular data set is compared with another data set. Here is the formula to calculate. First of all is variance, that is a squared standard deviation, and if we take a square root of variance, that is standard deviation. Look at this example. Now we have the same data set, number of sales calls received by different salesperson. Average was 3.25. So what we are doing here, the individual observation 4, 3, 2, we are deducting the mean. Okay, so we get the difference from the mean value and individual observation. We are squaring it, summing it up, and we are dividing it n minus 1. Then what we get is the variance, that is 1.92, and when we square root it, get 1.3887. That's the standard deviation. So this is the end of learning objective 2. Please see the next video for discussion on the subsequent learning objectives. Thank you very much.